Hi everyone, I am Rafael Valer from Brazil and I'm going to present our work entitled Musical Brush Exploring Creativity Through an AR-Based Tool for Sketching Music and Drawings. I am a master's student at the Federal University of Rio Grande do Sul. The other authors, Rodrigo Schramm and Luciana Nedel, are professors at the Federal University of Rio Grande do Sul. Charles Martin is professor at the Australian National University, and Jean Torresen is professor at the University of Oslo. So, a bit about introduction. Digital tools nowadays play a crucial role in the most creativity practices of our daily lives. From young children playing on tablets to create simple drawings, to professional artists who depend on advanced graphical interfaces to accomplish creative works. This growing link between digital instruments and creativity culminated in the emergence of a new subfield from HCI, which is named the study of creativity support tools. More specifically, this research focuses on the development of interfaces that aim not only the productivity, but also the enhancement of innovative potential. In this paper, we introduce Musical Brush, an artistic application that allows novices to improvise and create sounds through 3D interactions and drawings in augmented reality. The main idea is to provide people in general with a highly expressive artistic tool. We explore how the different interactions and visualizations could impact on users' creativity, comparing with more traditional 2D interaction approaches. So, regarding related works. Since early works, a large number of different interactions and technologies were explored on the conception of new musical interfaces. Here, we bring two examples that use gestural inputs to control music in real time. So we have Yamascope and the 3D in motion. One approach in particular is combining drawings with music. Drawings-based musical tools generally present highly visual elements, benefiting from the degree of expressiveness that drawings offer. The UPIC system presents a very early work in this direction, where users could use a pen to draw and generate sound at the same time. More recent works include MicroJam, where users can improvise short performances incrementally by creating drawings in several layers. Still, most of the research on drawing-based musical instruments focuses only on 2D interactions. Regarding this, immersive technologies have been explored to bring more freedom and expressiveness for musical tools. These technologies provide us with the capability to create scenarios not feasible in the real world. Some examples include the Reactable, which is an AR approach that uses tangibles to produce sounds, and Air Guitar, a VR guitar that resembles the real instrument through a cave-like room. To achieve this non-conventional approach for drawing-based musical interfaces, we have developed a novel interface named Musical Brush. It consists of a mobile artistic application and allows novices to improvise the creation of sounds and drawings in AR. The main idea is the mapping of user interactions to visual and sound outputs. As you can see, when moving the device, the application creates a virtual 3D trace along the path traveled. At the same time, it will also generate sounds. Here we show a brief demo video. Several techniques have been considered to achieve our current sound mapping design. By aiming an interface that can be used by people with different degrees of musical experience, we focused on implementing a one-to-one mapping approach, where each input parameter only affects one single sound output parameter. So, our sound mapping is as follows. The first mapped gesture is the screen touch interaction, which is mapped to the sound generation. So, as long as users touch the screen device, the application will keep generating sounds. The second gesture is the forced use to these touch gestures, which is then mapped to the sound amplitude. So, stronger touches implies on louder sounds. Another input parameter is the vertical position of the device, which will then impact on the sound pitch. Moving the device up will generate higher frequency notes, whereas moving down implies on low frequencies. The timbre of the sound is selected by a list of 4 prefixed waveforms, which include sine, triangular, squared, and sawtooth waveforms. Last, it is possible also to activate a delay effect, which is then characterized by an echo-like sound. This effect is activated by abruptly shaking the device. As said before, our interface is based on incremental composition of different tracks, which are then represented as sounds and drawings. The tracks are recorded individually, and users can also edit or remove it while they are creating a composition. Each of these tracks of 8 seconds length will execute at the same time, forming a more complex piece in the end. Regarding our evaluation, we were specifically interested in exploring these 3 items. If the design of musical brushes is successful in supporting creativity, what aspects of creativity are the most impacted, and what are the key features that impact substantially on this support? To reply to these questions, we made research on methods to measure creativity. Regarding this topic, we see several different approaches being used by the community, where observations and interviews are among the most used methods to evaluate the support of creativity. One work that it tries to standardize and objectively evaluate the support of creativity provided by tools is the Creativity Support Index. This methodology brings a survey that measures the evaluation of specific creativity-related attributes, as well as providing final scores for the tool. We then have used this methodology in addition to interviews and observations to be able to compare the results in a more concrete manner. In our study, we compared 4 different versions of Musical Brush to explore how different types of interactions and visualizations affect creativity. The AR is the original application, with no modifications. The SO stands for sound only and presents no visual feedback for users. The 3D immerses users on a virtual environment, removing the physical world from the camera image. Last, the 2D presents users with a version that users can only make drawings and interact directly on the screen, not using the device motion anymore. We conducted the experiment with 26 subjects on a within subjects format. The experiment took place on around 45 minutes and was divided in these 4 sections. During introduction, we briefly explained our objectives. During learning stage, the participants were introduced to the different versions of the tool. In the performing stage, participants were asked to improvise a piece for each of the 4 versions of the tool. After each version, they replied to the questionnaire concerning creativity. During feedback, we asked users to reply to a final questionnaire. So, regarding results and discussions, from the Creativity Support Index results, we observe a significant difference among the AR and SO versions for the attributes results worth effort, exploration, and expressiveness, as well as for the final CSI score. An unexpected result shows that both 2D and 3D versions presented an almost equal CSI score, with the 2D presenting even higher scores. When exploring how the visual feedback impacted on creativity, we were explicitly interested in comparing the AAR and SO versions. As observed, the final CSI score was significantly better for the AAR version, also presenting significantly better results for the other individual creativity-related attributes, such as the results of effort, exploration, and expressiveness. Moreover, we see a greater engagement from users while using this version, once that the duration time performing was also higher. Regarding the participants' opinions on the benefits of having visual feedback, they highlighted how the drawings impact positively on supporting exploration, immersion, and expressiveness. Another condition on our work was the exploration of different interaction and its relation with creativity. Despite the participants' opinion that the additional dimension increases the possibilities of exploration and expressiveness, from the CSI results presented previously, we surprisingly see that the 3D version did not present better results than the 2D. On an attempt to understand these results, we highlight the difficulties in controlling the tool mentioned by the participants, while detailing the negative points of the 3D version. Besides, when observing specifically the results from the attribute results worth effort, the 2D version presents even higher scores than the 3D. This outcome may be connected to the fact that, differently from the 3D, participants didn't need to move while performing with this version, once that all interactions were related to touch gestures on the device screen. This lower physical demand may be noted in some comments when asked about the advantages of the 2D version. The comparison between AR and 3D was performed within an exploratory approach, and despite the 3D not presenting an appealing environment to the users, results show that the participants moved more in this version. We believe that this may be related to the exploration of a new environment not previously known. Regarding the creativity support, the AR version presented higher scores on every CSI attribute. User feedback concerning the positive points of interacting with the real environment includes the ability to interact and draw with real objects, and an enhanced sensation of immersion due to the self-perception of being among the virtual strokes. So, our conclusions. In this paper, we presented Musical Brush, a novel drawing-based musical application that allows novices to improvise the creation of sounds and drawings. We conducted a comparative study to explore how different interactions and visualizations impact on creativity. Among the key findings, we discovered that the visual drawings are crucial for a significant enhancement on creativity support. More specifically, they were responsible for improving the expressiveness and exploratory capacity. In another discussion, although not presenting significant statistical differences, the comparison among 2D and 3D versions produced interesting results. Feedback indicated that 2D was preferred for rapid and efficient control of application parameters, while 3D was preferred for freedom and exploration of different ideas. Regarding future works, we see three different branches from now. First, we would like to explore how outdoor environments with more appealing objects could impact on creativity. Second, we would like to incorporate and evaluate the collaborative aspect. And last, we believe that exploring different timbres and more complex sound mappings could impact on the creativity support as well. Thank you so much for listening my presentation. Now we have 10 minutes for questions.